so it doesn't always work. Okay, so we're starting this lecture 15 minutes late. Sorry about that. If you're reading this lecture or watching this lecture later on, just look on OnCue for the course administration information. Everything you need to know is there. Lecture slides are here if you want to use them. The YouTube playlist of the videos, that'll be the link to that playlist. A lot of these, you'll see a lot of the lectures, there are no set of slides. I'm just going to be using the Jupyter notebooks directly. Okay, what else is here? Assignments and midterm solutions. So I always give you the solutions for all your assignments and midterms. They'll be posted here after the assignment and midterm are completed. Grading scheme we've talked about. I think that's it for administration. Anything else? Nope, that's it. Okay, so we can actually start this course. So I'm just going to skip through the notebooks. We'll get to that in a second. Okay, so what is this course about? All right, so some of you have to take this course, but this is not a required course for many of our programs. So this is called system level programming. If you read the calendar description, that's what it is. It's very short. It says basic concepts of Unix-like systems, shells and scripting, system level programming in C, software development tools and techniques. All right, so what is this course really about? And so what this course is really about is that it's, for many of you, it will be your first exposure to an operating system where you're not pointing and clicking with a mouse and using some sort of graphical user interface. And so we're going to be learning about this thing called the bash shell. Basically, it's a, basically the bash shell resembles an old school computer terminal. And so the way you used to interact with the computer is you would have a keyboard, there would be a screen, and all that you would see is text. So whatever you type into the keyboard, some text would appear on in the screen. You press enter, something happens. I'm going to show you how all that works later in this lecture. So we're going to be using something called bash. So it's the standard, well, it's not this, it's probably the most commonly used shell in Linux. We'll talk about Linux later. And you're going to be writing some scripts, which are basically bash programs. The other important part of this course is that you're going to learn how to program in C. Now, the C language and the Java language are basically the same. So the basic constructs are all the same, right? So declaring variables, writing loops, writing if statements, using braces to delimit blocks of code. It's all the exact same. That's because Java was intended to replace C, or that's one of its intents. That never really happened. So basically the Java language essentially took the C language and said, here, this is Java, we're going to add a bunch of extra stuff to Java, we're going to take away some stuff from C, and that will be Java. So I'm going to tell you what was taken away. I'm going to tell you the differences between C and Java. The reason this course is recommended for most students is because you have to take the architecture course. The architecture course, there's often taught using C. So if you don't take this course before taking the architecture course, you're going to have to take the architecture course and learn C on your own, which is perfectly doable. Excuse me, which is perfectly doable. Many students do it, right? If you're taking this course at the same time you're taking 221, it's actually not going to help you because we don't get to the C until like halfway through this course. And for those of you who are in, I think, software engineering, you have to take this course. And that's because a lot of the software tools you'll end up using in your career are going to be C-based. So you'll need to know about that eventually anyway. For everybody else, it's very useful to learn C. It will, compared to the languages you've been taught so far, Python and Java, C works at a lower level. And the things that you take for granted in a language like Java or Python, you'll realize the languages are actually doing a lot of the work for you. Because C doesn't do any of that work for you, you have to do it on your own. And so when we get to that part of the course, you'll understand, hopefully you'll understand how much heavy lifting languages like Java and Python are doing for you. All right, so the other part of this course is that it introduces you to the concept of an operating system. All of you have used an operating system or probably multiple operating systems, right? Your phone has an operating system, all of your computers have an operating system. The operating system is just the software that lets the user and programs written for that computer access the hardware of the computer, right? And so it's the thing that provides access to the CPU, to your disk drive or drives, to your USB ports, sound, video, everything, right? That all goes through the operating system. A program like PowerPoint or Word or something else, right? That's an application. It uses the operating system to access the underlying hardware, right? And then finally, the user, in most cases, for most people, I would say they never directly interact with the operating system itself, or very rarely do they interact with the operating system itself. Normally, they're going through some sort of application software, right? And so you're going to learn about writing applications that use the operating system or augment the operating system, right? That's what this course is about. All right, so in your everyday life, you're using computers. Almost all of you are going to be using a graphical user interface, so mouse or on your tablet or phone, your finger, right? You're going to be pointing and clicking at things, dragging things around, right? The alternative form of interaction is to use what's called a command line interface, right? And so that's basically you type stuff into a console, you can see what you're typing, you press enter, something happens again in the console. Right? You might wonder why in this day and age do we actually still need a command line interface, right? And so in your everyday life you don't, right? So for most people, they'll never touch a command line interface. Now the problem is that if you go out and into industry, you'll probably end up in a situation at some point where you have to access a server or servers. So for example, companies like Google or Amazon, Netflix, any of these giant companies, they have literally thousands or millions of computers. Not every one of those computers, in fact, almost all of them, do not have a screen attached to them. There is no command line, there is no graphical user interface. There's not even a screen, right? To access those computers, you have to remotely access their facilities, right? Typically using a console of some kind, right? So something that you can type into. And so this command line interface, very widely used in industry. Almost never used in everyday life, right? And so this is probably for many of you your first exposure to this. So we're going to be using the command line interface to interact with the Linux operating system. What the heck is Linux, right? So again, most of you not using Linux at home. Some of you probably are. There's usually 5 or 6 students who are. So what exactly is Linux? There's a link there if you want to read an introduction about what is Linux. So in brief, this thing called GNU Linux is a free as in beer, open source. Everybody can see the software that's written for it. It's an operating system widely used on servers, mainframes, supercomputers, and embedded devices. So it's very widely used in industry. You probably interact with it somehow in everyday life, even though you don't know it. Probably through one of these embedded devices. So an embedded device is just a device that has a computer in it, and you probably don't know it has a computer in it, right? So like the router or the Wi-Fi routers that are in this room, all embedded devices. Many clocks these days are embedded devices. Your car probably has 100 computers in it that you don't even know about, right? Controlling all the individual pieces of hardware in your car. All right, so how do you, so this course is in Linux. How the heck do you access it if you aren't using it on your home computer right now? CastLab, if you want to work on campus on one of our computers, CastLab does have a small number of computers that you can boot either into Windows or Linux. So you can access it that way if you really want to. If you have a Mac, that's basically close enough for our purposes. There are instructions on OnCue to install some software that you might find useful in this course, right? So follow those instructions sometime this week, right? To get your computer set up so that you can actually do everything in this course. The C stuff, you don't have to worry about that until roughly reading week. If you're on Windows, you have many options, right? The easiest way is to install, well, the easiest. So hopefully the easiest way for you to do this is to install Linux for Windows. So there's something called the Windows Subsystem for Linux that lets you run a Linux operating system in Windows itself, right? So you don't have to boot your computer into Linux. For most students, that's the easiest way to do this. There are other options, right? If you want to, you can install Linux on your computer alongside Windows, right? Another option would be to use virtualization software, if you know what that is. So you can set up a virtual machine on your Windows computer that's running Linux. That would be another way to do it. The easiest way is probably to set up Linux for Windows, right? Again, see OnCue for instructions. Bug me or one of the TAs if you're having trouble with this process. Right? Okay, so the rest of this class, I just want to show you the Jupyter Notebooks and show you some of the stuff that you'll be doing, well, introduce you to some of the stuff that you'll be doing in this course, right? And so I'm going to run this through the notebooks itself, so you don't even necessarily need to have a Linux operating system running at this point. That's not true, sorry. The notebooks need Linux to run, so I'm actually running the Windows subsystem for Linux right now. And the nice thing is it shows up in your web browser. And so when you get the notebook set up on your computer, if you choose to get them set up on your computer, the opening page looks like this, right? There's a little start here. You click that, you get that, right? And this is basically everything. Oh, wait, this is out of date. Hang on. I have to write this down, otherwise I'll forget. I don't remember if this is the actual current setup or not. So it looks like the C notebooks here are out of date. So these are the old ones. So I have to check if I have to check to make sure that the C notebooks are up to date. Okay, the bash ones should be fine, especially for today. All right, so one way to do this course is just to work through the notebooks on your own, and you never need to see me again except for the midterm or exam. That would be a perfectly feasible way to complete this course. I don't recommend it, but if you want to try it, by all means, go for it, right? So I will tell you that in a typical year, on the last day of class, there will be about 5 of you here, right? So I don't recommend you do that, but a lot of students do manage to get through this course relying only on the notebooks themselves. The notebooks are complete, so I mean, you could do it this way. All right, so I just want to take you through this, this notebook here, Introduction to the Command Line. All right, so you're going to be using this thing called bash. Bash stands for the Born Again Shell. I'll tell you more about shells in the next lecture. Basically, it provides a command line interface. So here, let me just show you what it looks like. This is the interface you get to your operating system, right? You type stuff in it, and it produces some output sometimes, depending on the command that you type in, right? And so the way that you interact with the system is you type a command. The shell reads what you typed in, tries to interpret it. If it makes sense to the shell, it executes the command, right? And the command will do something, right? So in this case, the ls command lists the contents of this particular folder or directory, right? This is the interface that you used to have to work with when you used a computer, right? This is all you'd see. I'm going to tell you more about this in the next lecture, right? Okay, so so a lot of this course is I'm going to be introducing you to these commands. How many commands are there? On my computer, there's probably somewhere around 5,000 commands. Does anybody actually know what every command does? No, no one actually understands what every command does, right? How many do you need to learn? Roughly like 20 or 30, something like that at the most, right? All right, so I'm just gonna show you some simple commands. I'm gonna do it in the notebook, but you could do all of these on your computer as well. So I could also do all of these, not exactly here, but using this terminal instead, right? So the commands will run here, or they'll run in your notebook, right? When you're learning stuff in the course, right, I recommend you do things through the notebook, right? And also have another command window open, and then try the same command in the command line itself directly, right? Okay, so suppose you want to print something on the screen, right? So the echo command is one command that will print a string to the terminal, right? So if I run that command, that just prints out hello world, right? Sort of like print in, or println in Python or Java, right? Okay, the command I just showed you is called ls, not 1s. So this is one of the confusing things about using the command line. The 1 looks a lot like the L, and vice versa, right? No command starts with a number. So, well, that's not true. I lie. A command can start with a number. None of the standard commands start with a number. ls will list the files in the current working directory. Now, what the heck does that mean? Right? So most of you are used to, so this is Windows Explorer, the File Explorer. So I'll go to my Documents folder, right? And you can see that in this folder, there are a bunch of other folders, right? On Mac, you'll use Finder, and you'll see something similar, right? A folder is called a directory in Linux, right? So my folder for this term, 2024F, right? That corresponds to a directory in Linux, right? What's in this folder? So if I click on that folder, you'll see there's a 220 directory or folder, right? And so directories, folders, can contain other directories, right? They can also contain, do I have anything here? Lectures, yes. So a directory or a folder can also contain files, right? So if you're working on the command line and all you see is something that looks like that, you might want to know what the heck is in the directory that the shell is currently in, right? That's what the ls command is for, right? So ls lists the contents of a directory, of the current working directory on its own, right? So there's an example. So here's an example of a command, echo, that needs an input, right? So echo needs to know what string to print, right? ls doesn't seem to need any extra inputs, right? I can just type ls and something happens. There's a command called cat. So cat stands for concatenate. And so if the only thing that you can see in a terminal is just text, right? The question is where is all your information stored on your computer, right? So where is the data that you're going to be using when you're in one of these command line interfaces, right? And the answer is the data is living in files on your computer. So one of the fundamental, or what you're going to see in this course is that a lot of the stuff you're going to be doing, you're going to be working with files, right? That's where all the information lives on your computer. So if there's a file called animals.txt, one of the things you might want to know is, well, what the heck is in that file, right? So cat concatenates files and prints the result to the terminal, right? So in that file animals.txt, it looks like there's 4 lines of text, right? Each line of text contains a string, right? That correspond to different animals, right? Oh, this is definitely an old, that's fruits. Okay, so I know that's a mistake. This is fixed. I know for a fact this is fixed on the online version of the notes. So I'm just running an old set of notes. So you can do the same thing with a file called fruits.txt, right? And it looks like there's 4 fruits in that file, right? Many commands in Linux will accept an arbitrary number of inputs, right? So I can cat the contents of 2 different files, right? And not surprisingly, you get the animals, right? Followed by the fruits, right? So cat, short for concatenate, right? Concatenates the contents of 2 files, outputs the result to the screen. So if you ever want to quickly look at the contents of a file, you can use cat, right? Obviously, if your file is very big, this is not so useful because you just get a big dump of information that's hard to process. If your file is very big, there's other tools that you can use instead. Okay, so again, all the information that you have in a command line interface, that information probably resides in a file of some kind. And so what can you do with these files? Well, suppose you wanted to sort the contents of a file alphabetically. Not surprisingly, there's a command called sort that does exactly that. So if I sort the contents of animals.txt, notice that it changes the order in which it prints things out in. Right? It used to be cat, zebra, dog, armadillo, right? Sort sorts the contents of the file line by line and then prints the sorted output to the terminal. So there are your sorted animals. Okay, so it looks like we've got these simple commands that I guess mostly operate on either something that the user has typed in, like echo, right? Or the contents of a file, like sort and cat, right? You might think, so what if I want to do something like sort the contents of both files and output that result to the screen, right? Well, I know how to print everything to the screen. Well, that's just cat, right? Can I take that output and pass it to another command? The answer is yes, you can, right? You use what's called a pipe. So that's the vertical bar, right? And so I can take the output of cat and send that to sort. So you can chain commands one after another. And this lets you take very simple commands that do one thing well. You can chain them all together and end up producing a very complicated result, right? So if I do that, I get the animals and fruit all printed out in sorted order now, right? So apple, armadillo, then cat, then dog, mango, pineapple, strawberry, zebra, right? And so later on in the course, probably in a few lectures or so, we're going to be chaining a bunch of commands together and to produce more complicated computations. Okay, there's a command called grep. I forget what the G stands for. Grep searches for a pattern. And so the pattern is defined by another language, right? And so when you're learning Bash, or in this course, you're not learning 2 languages, you're learning a third, right? The third language is a regular expression language. Right? So a regular expression is just a pattern. And the pattern lets this program called grep search for things that match the pattern in a file, right? So this funny pattern, that's the caret, so Shift-6 on most keyboards, followed by the A. That pattern says find all lines starting with the lowercase a, right, in the file animals.txt. So this will list all the animals that start with the letter A. Right? That's armadillo. Right? Okay. The pattern P means look for the P anywhere in the file. Right? So grep will search all lines of the file. If there's a line that contains a P, it will print that line. So the fruits that contain a P, pineapple and apple. Right? Not surprising. Okay, so when we learn about grep, we'll be learning how to specify these regular expressions. The date command. All right, so if all you're staring at is a console like this, and this really used to be what you used to, all you would have, you might want to know what time is it or what is the date, right? Date command will do exactly that, right? So the date on a Linux computer will print this. On a Mac computer, it'll print something different. So this is one of the important things that you need to know if you're using a Mac. If you're using a Mac, your operating system is not Linux. It's based on something else, right? Many of the commands that I show you in this course will run on your Mac. However, the version of the command that you're using on your Mac is different than the one that I'm using in this course. So date might output something different on your Mac, right? So on most of the assignments, I try to be operating system agnostic. So in other words, it shouldn't matter if you're using a Mac or Linux. Some of the assignments will indicate to you, though, that if you're using a Mac, you have to make sure to use the Linux version of the command. And so on a Mac, if you follow the course instructions, the Linux version of the commands all start with the letter G. So there will be a G date, there will be a GLS, and so on and so on and so forth, right? Okay, I haven't shown you this. So there's the date, but you might want to know something else, right? So I might want to know what day is it. So I don't care that it's September 3rd. I just want to know it's a Tuesday. I might want to know what is the time. I don't care what day it is. Or I might want to know what the year is, or any one of a number of other things. So many commands in Linux, almost all, let you specify options to the command. The options change the way the command works. This is one of the confusing things about learning this command line interface like Linux, right? Not only do you need to know the commands, you need to know the options that are associated with the command, right? So date minus big I date prints just the year, the month, and the day, right? And there are a multitude of other options for a command like date, right? Date's pretty simple, right? Prints the date. But if you actually look at the documentation for this command, you'll see there's a whole myriad of options that you can use to change the way that the date is displayed, right? Later on in the course, I'll show you how to specify options. I'll show you how you can learn about options. and how do you use them, right? Cal prints a calendar. On its own, it prints the month, shows the current date, right? Again, right, in today's day and age, right, who cares, right? I've got this thing in the bottom right-hand corner. It tells me everything I need to know, right? Your phone's got a calendar application, right? Again, right, back in the day, when you're just staring at this, right, it might be useful if there was a command that showed you a calendar, right? And again, just like date, you can specify a bunch of options. -M lets you specify the month, right? -M1, print the month January for the current year, right? Do you want the whole year? -Y will print the entire year. Looks messy here because I'm in the web browser, not on the terminal. Okay, what about some silly commands like fortune? Fortune prints a random adage, right? So fortune's got has a file somewhere or files. Inside those files are just random sayings, and many of them are humorous, right? So this will just print out one of these at random, right? So this prints out all the troubles you will pass away, very quickly. If you run it again, it'll print out something else, right? So there's a quote from Shakespeare, right? Run it again, prints out something else, so on and so on and so forth. One day this is going to get me in trouble. It's going to print out something rude. It hasn't done it yet, but there we go. All right. Again, you can chain commands together, right? So suppose you say, hey, look, I don't want to print out just the fortune. I want to make it look nice. So I can take the output of fortune and send it to a program called cowsay. And that prints the fortune using a cow to say the fortune, right? Other fun commands, there's a command called, it's spelled toilet. What does it mean? Oh, it actually stands for the other implementation's letters. And that refers to another command called figlet, which is Frank, Ian, and Glenn's letters. All this does is it uses some ASCII, oh, this doesn't look very good, sorry. It uses some ASCII text to, it prints out text using ASCII art. Let me do this in the terminal. It might look a little easier. Oh, sorry, wrong one. It may look a little easier to read, it may not. Okay, so, whoa, toilet. Oh, wait, sorry. So run the fortune command, pipe the output to toilet. There you go. So it looks something like that. So what does it say? You'll wish that you had done some of the hard things when they were easier to do. Right. I guess that makes sense for students. All right. And there's a whole bunch of other, so again, there's like thousands of commands on my computer. We're going to learn about the useful ones in this course. There are silly ones in this course. So there's ls, list the content of a directory, right? If you do it backwards, you get steam locomotive instead, right? This is just a silly program someone made up. So you can imagine that if you're typing stuff in a terminal, right, like ls, and ls is one of the commands you use over and over and over again, it's very easy to type it in incorrectly, right? This might correspond to a command, right? On most Linux systems, it doesn't, but I've installed the SL program and it does this instead, right? There's other silly stuff as well. What is the matrix one? You can play Pac-Man. I forget how to do it on here. So there's an actual runnable version of Pac-Man that you can run in the terminal. The fact that you can do this in a text-based terminal is amazing. It's like the amount of programming that went into this is hard to believe. But other silly ones, you can get this. So there's the scene from The Matrix. I guess many of you have seen it. Some of you may not. Stop. Go away. Okay, there you go. Right. If you ever run a command and you can't get it to stop, Control-C will probably get it to stop. Right. And so on and so on and so forth. So a lot of this, the first 5 weeks of this course, roughly, is going to be me showing you how to use commands in Linux. Right. Again, if you want to get a jump start on the course, just start working through the notebooks on your own. Right. Have any questions? Come to class and ask them. Fire me an email. Come to office hours. Do something like that. Right. Again, all the instructions for getting this stuff set up are on OnCue. So go to course readings and resources. Do I tell you? Yes, something's missing. Okay, one other thing is missing for the Windows users. I have to tell you how to install the notebook software on your computer. So I will update OnCue in the next day or two, and you can get your computer set up for this course. all I have for you today. I guess I'll see you in a couple of days.